Some of us have been around long enough to remember a time before the internet, before cell phones, and before personal computers. Yet there's still another generation that has never lived without any of that technology. Whichever group you're in, computers and the digital era have revolutionized the way we live our lives. On today's CTSI Discovery Radio, we'll look at how the computer age and sharing biomedical data has changed the way we do research, how quickly we can do it, and have a more profound outcome. Meet the people who are making it happen next.
We are the robots. We are the robots.
Good day, Southeast Wisconsin. I'm David Todd. Recently, the National Science Foundation announced 4 awards totaling more than $5 million to establish regional hubs for data science innovation and sharing, what is called big data, among research institutions. But the Clinical and Translational Science Institute of Southeast Wisconsin has already joined partners across the area and across the country to get to work on advancing biomedical innovation more efficiently and with lower costs using big data. But first, let me tell you a bit about CTSI, or the Clinical and Translational Science Institute of Southeast Wisconsin. We are a consortium of researchers, scientists, doctors, and others working together in collaboration to advance biomedical research and to find new drugs, therapeutics, and interventions faster and more cost-effectively than ever before, using now existing patient data to study. Our first guest, Bradley Taylor, is Chief Research Informatics Officer at the Medical College of Wisconsin and co-principal investigator on many of the big data projects CTSI is working on. Brad, can you first start by telling our listeners what biomedical informatics is and how it's used in healthcare?
Biomedical informatics actually has multiple titles. So there's biomedical informatics, healthcare informatics, medical informatics, nursing informatics, clinical informatics, and they all really mean the same thing. It's the disciplinary field that uses healthcare information technology to improve healthcare via a combination of higher quality or higher efficiency and new opportunities utilizing informatics and technology.
We keep hearing the term big data. Can you tell us what that is and how you're working with it?
So big data is actually a culmination of information being collected from various healthcare information systems. So it's really large amounts of fast-moving, semi-structured and unstructured data that cannot be handled by traditional data management tools, mostly due to its complexity. When we think of big data, we think of data in using the 3 V's: volume, velocity, and variety. So how is the velocity of the data coming at us? Is it batch? Is it real time? Are we talking about megabytes or terabytes or petabytes of data? And from a data variety, it can be anything from data stored in a traditional database to looking at social information and video and web-based information to understand how data is moving within the ecosystem and how what trends are being generated from that data.
And could you give me an example of how biomedical informatics is being used?
So when we think about biomedical informatics, we can think about data coming from a variety of sources. Like I had said earlier, social media is one way to look at the trends of individuals in our country and around the world. One of the more interesting stories most recently was with regards to the Ebola outbreak in Africa. And there was some interesting things that were done during that period of time where there was a large amount of mobile devices that people carried in that area of the world. And we're actually looking at telemetry information to see how the movement of individuals and what the spread of Ebola was doing across the country so we could predict where the next potential outbreak might be. So there's a lot of different ways to work with that data, to visualize it, to summarize it, and the bounds are endless here. We can do so many different things with the different types of data that can come at us.
And one of the types of data you're able to use is patient data. But just to be clear, patient privacy is never compromised by the process called de-identification. Can you tell our listeners how de-identification works?
So HIPAA regulations require us to de-identify data with this 18 safe harbor identifiers, such as your name and your address and your birth date and your social security number, the zip code that you live at, etc. So what we do is we actually strip all of that information out to allow our investigators or scientists to view that data without knowing who the underlying people are, by removing all of those safe harbor indicators. By doing that, there's no way to track back who the original person was because there aren't identifiers associated with those. But we do have mechanisms with IRB protocol approvals to actually crosswalk back to the real identifiers on an as-needed basis. But generally, we try and strip all of those out.
So now you have access to exponentially more healthcare data than before. What does that help you and other investigators do?
So understanding what our population, or patient population within our healthcare system looks like is one thing, but when looking at, let's say, the state of Wisconsin population health, if we start aggregating data across multiple health systems, we can now visualize our patient populations to understand where there might be pockets of disease that we would need to understand better, so there's more research can be focused in that area. We can understand immunizations and look at how the immunizations are affecting outcomes for certain patient populations. So larger data or healthcare data allows us to be able to visualize and look at outcomes for greater populations, to look at norms as opposed to our smaller healthcare system here in southeastern Wisconsin. So we can look across multiple states or across our entire state population.
And the Medical College and CTSI are part of several large data consortiums. Can you just tell me a few of those?
So we're part of something called the MARCH Consortium, which is the Midwest Area Research Consortium for Health. It includes multiple CTSAs, such as the Indiana University, Mayo Clinic, the Ohio State University, University of Minnesota, University of Wisconsin-Madison, just to name a few. I think there are some others that are looking to join that at this point. We're also part of something called the PCORI, or Patient-Centered Outcomes Research Institute, CDRN, or Clinical Data Research Network, specifically the Greater Plains Collaborative within those networks. And that includes 12 academic medical institutions now. So our networking opportunities have greatly expanded, and our opportunities for looking at rare populations as well as population health across the Midwest region has been significantly enhanced over the last couple of years.
I was going to say, that sounds like an incredible expansion of resources.
Yeah, it is. I mean, these are some very unique collaborations, and NCATS, and as well as PCORI, another funding stream from Congress, have really started to push these collaboration opportunities and multi-institutional collaborations to make sure we're looking at diverse populations across the wider region so we can understand healthcare outcomes.
And lastly, the use of big data is being encouraged by the National Center for Advancing Translational Science, or NCATS. What have you seen change over the past few years coming out of the NIH, NCATS, the National Science Foundation, the CDC? How are they forwarding the use of big data?
So I guess if we look at data being collected over the last, actually, couple of decades, and I know you said the last couple of years, but over the last couple of decades, we've seen just an absolute explosion of biotechnology information. Give you a couple of examples here. Data storage in 1990 could fit on about 3 floppy disks, and today we're looking at about 400 million 4-drawer filing cabinets to store that information. So based on that, these collaborations across our institutions are really important, and NIH has been issuing BD2K, or Big Data to Knowledge Awards, over the last couple of years. So we're really looking to enable the data that we've been collecting and allowing ourselves the opportunity to analyze that data and develop new software methods for interrogating that information. They're enhancing training around utilization of big data, again, new techniques, and then creating centers of excellence across the country. So there's a lot of knowledge around big data itself, but how do we utilize it is kind of a growing concern. And NIH is really looking at creating opportunities for us to utilize that data in a better fashion and improve the outcomes of our patient populations.
Brad, thank you so much for your time and sitting down for us. I really appreciate it, and it sounds like you've got a great team that's doing some excellent work in advancing science, just as our mission is.
Thank you so much. I appreciate it.
In 2013, the National Center for Advancing Translational Sciences, or NCATS, along with Life Technologies Corporation, announced that, for the first time, large-scale data on biomedical makeup of small interfering RNA molecules are available to the public. Since then, NCATS has been a big proponent of data sharing. On the other side of this break, we'll meet Dr. Jay Urbane of the Milwaukee School of Engineering to tell us how engineers are getting into the work of biomedical informatics. That's next. Our next guest is an engineer at the Milwaukee School of Engineering. Dr. Jay Urbane is an associate professor in the Department of Electrical and Computer Engineering at MSOE and a leading member of the CTSI team. Dr. Urbane, you're a co-principal investigator on the CTSI grant and several others that support the use of de-identified data and natural language processing. How does having that as a resource help you and others in research?
Well, to start with, I developed a de-identification software, and I used the de-identification software to further develop it. It may sound a little crazy at first, but we started off with samples of data from Frater Children's Hospital to develop and to test the de-identification software. And when we notice something's not working, I basically take those examples that have been already de-identified, and I've written some software to actually regenerate those as patient records, but with false names and things like that. So actually one real principal use for me is to further develop the de-identification software itself. Other things I've been working on are search techniques, so we can both do integrated search of both the discrete data in the data warehouse as well as the unstructured text in a uniform way. So there's many things along that and augmenting that search capability we've been working on. So like one thing is identifying medical concepts in the text, identifying, perhaps things like heart rate risk events associated with particular cohorts of patients. Okay. For example, diabetic patients. There's a lot of things in the text. There's a lot of knowledge there that isn't captured in discrete database fields. Mm-hmm. Another physician, Meredith Adams, is interested in identifying attributes of pain for patients, let's say, that have lower back pain and might be on opioids and things like that, and studying how that's affecting them.
When you said that you had developed some de-identification software to help you further develop de-identification software, how do you actually do that process? How do you take a patient record and take away all the personal information? Is there a process? Is there some sort of a logarithm or something like that?
Yeah, basically it has multiple steps to it. So basically, for my development, my colleagues in the biomedical informatics group, like George Kowalski, Brad Taylor, Glenn Bushy, they've helped with this a lot. I initially evaluated existing systems as best I could, but the existing systems had trouble with the data that we have at Frater and Children's, and also had performance problems. So we have like over 48 million patient records, and it would take us weeks, if not months, to de-identify everything. And then once we had it working well on the benchmark data set, we moved to real data. And to evaluate it on real data, it's pretty time consuming. We identified 48 different cohorts of patient records, and clinical notes vary a great going from one clinical domain to another. How they abbreviate things, how they write, the kind of grammar they use is really different. So we sampled data from each of these 48 groups of data, and then we carefully inspected 1,000 samples randomly selected from each of these groups randomly.
So when you say cohort groups, these are other collaborators of yours, so that you can see how they're using their data, so it can be used in conjunction with the data set that we're using in de-identification. Is that correct?
Right. That's right. Right. So, let's say patient records from cardiology, the terminology they use are quite different than someone maybe in pathology or an endocrinologist would use with diabetes patients. Okay, so that's how we develop the software, and then there's a number of software stages to do it. So basically we read each record in, we turn into sentences, and then we take the sentences and turn them into tokens, where we determine things like part of speech, and we look for noun phrases. And those noun phrases essentially are candidates for maybe a disease name that might be useful to keep in there, but it could be a patient's name. And then we have software that goes and looks for like email addresses, phone numbers, physical addresses, things like that could be that are protected health information, and then we convert that so it's de-identified.
It's fascinating, and it seems like a work-intensive process. So let me ask you this. Since becoming a CTSI member, have you seen a transformation in the way that you do your work? And can you tell me how that's happened?
Probably the biggest transformation in my work has been the opportunity to work with colleagues affiliated with the Medical College of Wisconsin. That's been a really positive experience. I'm mostly interested in doing things not just from a research perspective, but also from an impact perspective. And I really like the mission that they have and the kind of applications that they're working on. So I'd say first and foremost, it's the opportunity to work with these colleagues. And it's just like this 1 + 1 = 3 kind of equation. You get a computer scientist together with a research physician and maybe another IT person. Just good things happen because you look at the problems from different perspectives and you bounce these ideas off each other, and it's a real positive experience. So I'd say that's that's good. The other thing is, I myself have actually filled out a CTSI data evaluation form, and that way I'm able to access large number of patient records that I can use for further natural language processing and search development. Physicians have come to me and they said, well, how can we find this kind of information in the text in a patient record? So using that de-identified data, I can say yes or no, and I can say how difficult it'll be. So that helps foster their research as well.
In addition to CTSI fostering the collaboration, since you've been able to work with large amounts of data, has it expedited your work?
I'm more in the supportive role. So I think with me and other colleagues at the biomedical informatics group, it's helped facilitate the work of others. Now, I guess it really has. If you think about it, by just filling out a data evaluation form, as opposed to going through a whole internal review board process, that saves a lot of time. It's a huge time savings. And I think as I look kind of forward, I think what's really exciting is that over time, we've kind of done science kind of empirically. Like we see something in the world and we make a hypothesis about how it works, and then we create an experiment to do this. In medical applications, physicians do the same thing. And then on top of this, forming this hypothesis, they have to be very specific when they're dealing with patient data, go through an internal review board process, which can be lengthy and time-consuming, and then things may not work. And maybe they didn't select the patients and things like that, or maybe they have to go back and read patient records. Now with a warehouse and with de-identified, you don't have to go through that whole internal review board process. And you can evaluate hypotheses much more quickly. And in fact, that's the whole idea, I think, behind this whole notion of like e-science is that it's not just empirical. People can maybe use the data interactively and generate their own hypotheses in that way without actually having to formulate the experiment first, but interactively work with the data. You know, they don't have to go out and get a clinical trial going, all this other stuff. They can just work with the data directly and see how well it pans out.
And they can almost get pilot data for a beginning of a research study from using the data that's available to us.
Yeah, it's really flipping things around, you know, designing a study, getting an IRB, and then actually doing a clinical study to get the data you want. Well, that data may already exist for you. That's pretty positive. That's pretty interesting.
Yeah. Jay, is there a specific example that you can share with me of how you've used data to expedite somebody's research study?
Yeah, with a Dr. Truitt and a Dr. Knudsen, we put a grant together last year, and we wanted to see if we can identify heart risk events. And using the de-identified data, I was able to come up with some basic ideas for algorithms and see how well it worked. And then we subsequently took part in an I2B to NLP challenge to do such a thing. So having access to that data allowed me to try these things out really pretty efficiently.
Okay, I have to ask you, what's an NLP challenge?
Oh, okay. So different consortiums, they put together academic challenges. They don't like to use the word competitions to see how well your algorithms work.
Gotcha. Dr. Urbane, thank you so much for your time. I appreciate you sitting down with me. And I really appreciate your excitement around using data and collaborating with the other partners of the CTSI.
Thank you very much.
One more quick break, and we'll introduce you to Dr. Russ Waitman from the University of Kansas Medical Center and another partner of the CTSI.
One is the loneliest number that you'll ever do. Two can be as bad as one. It's the loneliest number since the number one.
Our next guest is the principal investigator of the Great Plains Collaborative on Research, Dr. Russ Waitman from the University of Kansas Medical Center. Dr. Waitman, as PI for the Picori Great Plains Collaborative and the director of the Biomedical Informatics at the University of Kansas CTSA Hub, how has collaborating with big data impacted the work or the amount of studies that you're able to support over the course of a year?
That's a good question. I would say we're seeing really an ability to support investigators in a way they couldn't do before. So I'll give you some examples.
Excellent.
Previously, to do a lot of these studies, it depended upon chart abstraction. So poor students would have to go around and look at charts to pull data together. Mm-hmm. So they would never even be able to do the types of studies they can conduct today on hundreds and thousands or hundreds of thousands of patients. So what we're seeing is investigators, and especially kind of those young, intellectually curious people, are able to start down a research track that before would not have been possible for them. So that's probably, I would say, how big data, in one sense, is most impacting research. And really, the key cornerstone to this is, as you know, for the longest time, the only electronic data really available in mass on healthcare was billing information.
Right.
And now that people are adopting electronic health records, you now have the more clinically relevant information that's very critical to understanding health that's now available electronically. The most classic example, and it's a cornerstone of the work of the Greater Plains Collaborative and our funding agency, the Patient-Centered Outcomes Research Institute, is obesity. So just a simple thing like how heavy is someone, or what is their body mass index. So that's kind of a measure of height and weight that gives you a sense of how round somebody is. That's something that on all these billing analyses that had been done for health services research for decades, they would never know that very simple fact of how much does the patient weigh and how tall are they. So having that type of data coming from great places like Milwaukee on hundreds of thousands and millions of patients allows people to understand the impact of obesity on health, which was not possible before. So we're seeing more use of this data. We're fulfilling, many data requests a year to look at large data. And now with the leading work your institution is working with us, we're able to start to support investigators to look at this type of information across the country. And I'll give you one more specific example, because I was just talking with our colleagues at Iowa. So the University of Iowa is also in our network.
Right.
And they commented that we had a project for our Phase 1 work in the Greater Plains Collaborative to look at the breast cancer patients in our network. And we were able to deploy a survey of these patients by looking at tumor registry characteristics and EHR characteristics, and then contact patients to see if they would be willing to fill out a fairly involved survey on their journey through recovery, and treatment of breast cancer. And we had great response from all the states and all the cities. And the lead investigator at Iowa commented that, this was a study that we were able to do on over 1,000 patients that was enriched with all this valuable data from the EHR and registries collected electronically that previously would have taken an order of a magnitude more funding to approach what we could do in a much more straightforward manner. And that was all possible by having access to, quote, big data, kind of integrating electronic health records with other valuable registries and records held by our institutions.
Well, I guess that leads me to my next question then for you, Dr. Waitman. What excites you most about having this large consortium, the Great Plains Collaborative, or GPC, accessible to your investigators?
Well, I would say, and, mainly you feel a lot of responsibility to say, how can we make sure we get the data right and get the infrastructure right so we can scale up to support as many people as possible? I think what's been most exciting has just been the colleagues around the country and around our institutions working together. So it's being able to meet the needs of investigators who've got bright ideas to advance our understanding of health, or we're also working with investigators that are trying to conduct trials that might determine what medications are most effective for treating patients with conditions. So, it's being able to both manage getting us to work together as teams to support large-scale research, which wasn't possible before. The other exciting part of that, in a way, as more of a computer informatics guy, is that a lot of us in our network have really good teams that are kind of on, let's say, the smaller side compared to maybe some very large institutions that have been around informatics for a long time. So it's also really exciting to kind of create a sense of community across our region of people who can share lessons and work together. That is, I think, a real value for the teams working on the project.
So in addition to all of the information you now have at your fingertips, it's really the ability to interact with other biomedical informatics people from around the country that really has your investigators energized about this collaborative.
So I want to point out that if you have ever heard of an institutional review board, oftentimes investigators view those individuals or that office as kind of a barrier. Our IRB officials across our network have been the most proactive people to work with to figure out, now, how exactly can we try to streamline research so that we get the permissions in place that will allow people to conduct trials much more efficiently. So instead of, if you wanted to do a trial at 13 different centers, you'd have to submit IRB paperwork through 13 different offices. If we can get people to come together and agree to have someone act as the lead, that type of streamlining and working together as a community of regulatory officials is hugely valuable and hugely exciting to see that type of work happening. Similarly, to get our legal attorneys together across our sites to work together on what's an acceptable way to manage sharing of data is hugely important to building kind of the legal foundations and the regulatory foundations that enable our investigators to work together.
So doing this in collaboration really has expedited and made it much more efficient for your investigators and for all of the colleges and universities and research facilities involved.
Yes, and I will say, we just finished our 18-month initial phase, so may still be a little bit rough around the edges at times, in terms of having the processes totally refined. But without this type of project, there was not anything initially on the horizon that would really make it easier for investigators to kind of plug in and work together. So the whole project has really, I think, catalyzed work across not just a region, but across the country in terms of how we can align our information, but also align our processes to allow investigators to connect to each other. It's been really amazing to work with the folks up there in Milwaukee and across the upper Midwest. Specifically, your team and the collaboration there in Milwaukee between the medical school and the School of Engineering with Dr. Urbane has been really neat. We're one of the pilot sites to try to take their methods for de-identifying notes. And we're re-implementing that software that he developed and shared with us. That's some critical infrastructure work that's being led in Milwaukee for our institution down here in Kansas, and we're very grateful.
Well, Dr. Waitman, I thank you for your time, and I thank you for your enthusiasm. You really have an energy and an excitement around this, and I think it's appropriately placed because this is very important information for our researchers.
Right. Well, thank you for spending time with me.
If there's a better, faster, more efficient way to collaborate, our CTSI members are going to find it. I'd like to thank all my guests for joining me today. And next month, don't miss our program on a new collaborative stroke program that could give survivors more confidence in their recovery. Until then, CTSI, or the Clinical and Translational Science Institute of Southeast Wisconsin, is an 8-member consortium, including Children's Hospital of Wisconsin, Froedtert Hospital, Blood Center of Wisconsin, and the Clement J. Zablocki VA Medical Center, as well as the Medical College of Wisconsin, Milwaukee School of Engineering, Marquette University, and the University of Wisconsin at Milwaukee. All 8 institutions work together to accelerate the discovery and development of new treatments and interventions that will improve our community's health. If you'd like to find out more information on CTSI or other CTSI Discovery Radio shows, just log on to ctsi.mcw.edu. There you'll find more than a dozen programs on research and the community. You've been listening to CTSI Discovery Radio, produced by the Clinical and Translational Science Institute of Southeast Wisconsin, in collaboration with WMSE Radio. The show is engineered by Tom Crawford, with special thanks to Santi Everetts and Doctors Matthew Panhans and Reza Shakir.
She blinded me with science.